All right. So, what we were going to begin with is talking about the negative and positive properties of air. So, how do you know that air exists? Can't feel it. Can you feel it? Can you taste it?
Well, actually, yes, you can feel it.
How can you feel it?
Either by the wind or when you're breathing in.
Okay.
So with this balloon, how would you show that there's air?
Would you be able to use that
How do you
balloon
know?
to show that there's air in it?
Because if you let it go, it's going to deflate. In order to fill it up, it either has to be filled with water or air.
Okay, because it takes up space, right? So that's one of the things we know about air is it takes up space. Another thing is you said you can feel it moving, right? Like when you stick your head out of the car, you can feel the wind kind of blowing, right? So that's another way, kind of similar to the balloon.
So here, you guys can blow up your own balloons and practice together.
And try and just think of ways that you can prove air is real. Because we know that we can't taste it. We can feel it sometimes. Can you see it?
No.
Could you ever see... Could air ever move something so that you could see that thing moving?
Yeah.
So that's kind of, you can see it move, right? Right, a piece of paper. Okay.
Do either of you need help blowing up balloons?
I don't think so.
Let's see it.
I'll blow up some more just so that we have extras.
Yeah, no, I can't blow up balloons.
So we have one balloon, this one.
That was too much. Okay, how about that? You can hear air, right? That's another thing we can do.
Especially when you're riding your bike, you can hear the air.
Going by, right?
Yeah.
And on the car too.
Why is this one shaped weird?
I think that's because there's so much air in that one.
Okay,
It looks like a light bulb.
Strange.
so our next experiment that we're going to talk about is what happens when you poke a balloon.
It pops.
It pops. Do either of you think that there's any way that you can poke a balloon without it popping?
Yes.
Like say with this. What are your ideas of how you can do that?
Once I tried, if you put a piece of tape on the balloon and then you try and pop it, it won't deflate as fast.
So the tape will hold it in? Yeah. Do you have any
Interesting.
ideas of other ways that you can do that?
Or do you think it's gonna pop?
It's gonna fall.
Okay, good. We have
Okay.
different.
So I'm going to give you each one of these spheres, and you can use the pokey end to try to see if there's any way, just by now, if you can do it. So you might pop the balloon, so prepare yourself. There goes one. Now your turn to try. Do you want me to hold it for you? Okay.
Okay, that one was huge.
Okay. What if I told you that there's a secret to being able to pop or to make a sphere go through the balloon without it popping? Do you guys think that that's possible?
Yes.
She already thought it was possible. Do you think it's possible now? Okay. The balloon is actually made up of tiny little molecules, and they're called polymers. So that's a chain of molecules. And polymers expand. That's why these balloons can stretch. And when you stick something through the polymers, and you do it very slowly while twisting, you can make it expand, and then it closes back around, and it helps seal up that hole. Does that sound like it makes sense to you? Like something that can happen? So, what we can use to help that is Vaseline, or you can use olive oil, and that will help you. So, I'm going to let Casey do this part, and we're going to switch.
Okay. So, one of the things that we know about air and what makes up these pieces of balloon is that they're made up of tiny, tiny little molecules that we can't even see, right? And so we know that there's air in here because it takes up space, right? So there's these really tiny molecules inside of this balloon that are making it like a circle. So what we need to do is we need to stick this in without letting any of those little molecules get out, right? So what do you think? Should I go fast or slow? What do you think?
Slow.
Slow, right? Why?
Because if you do it fast,
It will pop, okay? What do you think?
because if you do it fast, the molecules wouldn't be ready, and it would go straight through and it would just go bang.
The molecules have an easier time to escape if I go quick, right? But if I go slow, and I can slowly separate the molecules of the balloon so that they kind of form around this balloon, around the stake, then none of the air molecules have a chance to escape, right? Okay, so let's see if I can do this first try. Hopefully.
Sometimes it takes many tries.
And do you notice anything about where I'm sticking
The top.
to the top, right? Now, why do you think that would have an effect?
Because it's less stretched.
Ah, how do you know that?
Because at the end it's really light, but at the bottom it's darker, and the darker color was there first, so you know that it's stretched out more.
Okay, awesome. The polymers are way more stretched out here. The molecules of the balloon are way more stretched out right here, right? Whereas right here, where I went through, and even right here a little bit, it's way darker. They're less stretched, right? So we know that the balloon, the polymers are thicker right there, so it's better to go through right there. Yeah? Okay, let's try it. See if you can do it, okay? So it's better, sometimes it helps a little bit when the balloon isn't quite filled up so high. You can try this one, that works perfect. So go ahead and blow one up. And then dip it in the, oh, do you have any ideas about why this might work? Why this might help? What do you think?
Because it's slippery.
Okay. Because it's slippery? What do you think? No idea? It's just weird, huh? I know, that's what I thought. But what it does is it just helps make a seal, right? Because all we're trying to do is make sure that those air molecules don't leave. Which is what causes the buffer. So, pretty cool, huh? And it'll stay like this for a day, 2 days. Just like this. So here, dip your stick in here. Get some, get it all over there. That's more than better.
So remember, the trick is to twist it and to go very slowly.
Nice and slow, just sort of.
And at the top.
And at the top. Very good.
Oh, she's in.
Got one?
Oh, all right, cool, it worked.
Ooh, mine is so stretched out.
All right, so
that
now.
I can actually see it going through.
Yeah.
Yeah, yours is really stretched out. So
It's a great observation.
we need to exit right through here, right? So you can leave that part, and now you have to make sure that you're pushing it right through there. Nice and slow. This one is so close, I can feel it. It's like, it's there.
I can almost.
There
we
it
go.
goes.
We got
She
one.
did it. There it is. Look at that.
Let's see the second one. Very nice.
Pretty cool.
Although I did notice that it was harder because the Vaseline all came off when it was first pressed
On the first hole.
in.
So the second hole is tougher, right? Because there's less of that seal that helps the air from getting out. Good job. You guys did awesome. So
Very nice.
we'll do a recap of everything we learned. What did we learn about air?
We learned that it's see-through
It's see-through for sure. What did we learn about how do we know it's there?
because we could feel it.
We can feel it.
We
What else?
can see things that it moves.
Awesome. And it takes up space too, right? And it was trying to get out of the balloon, and we were able to move the molecules slowly enough that we didn't let it get out, right? Awesome. You guys did great.